in this example, we have the sum n equals 2. Why 2? If it were 1, we'd have issues, right? We'd have division by 0. Creates a black hole. It's terrible. So it's the sum from n equals 2 to infinity of 1 over the square root of n minus 1. Now, square root of n, think rational exponent. It's n to the 1/2. So ideally, we could compare this to 1 over a p-series with p equal to 1/2, right? Yeah. So that's what we're shooting for, Tex. So number 1, we want to compare, let's actually go ahead and write it n to the 1/2. 1 over n to the 1/2 minus 1. Okay, what do we want to compare this to, and where does it go?
Something smaller, so that
Okay, so what happens if, ideally, we just delete the 1, right? So if we do that, is this correct? Is 1 over n to the 1/2 going to be less than 1 over n to the 1/2 minus 1?
yeah, because you're making the denominator bigger.
Exactly. When you take off the minus 1, you're making the denominator bigger. So this is true, isn't it? Okay, now what else do we need on the end here? It has to be bigger than 0. Both of these have to be bigger than 0, so we'll put that in there. And that's, obviously it's strict because n is a counting number. Well, 1 over n is never going to be 0, right? And n is positive. Okay, and it starts at 2, so that's not a problem. So that's good. Now, what series then do we look at? So we could say now, don't forget to write down the summation notation. That's what students tend to forget on the test. It's the sum, not just the sequence. So the sum n equals 1 to infinity of which one are we looking at? Of
1 over n to the 1/2.
yeah, the one we created. The sum of the sequence we created, right? Well, what does that do?
Diverges. It's p-series. P is 1/2, which is less than 1.
Good. Diverges, and I'll say, I like to do it all in parentheses, the explanation. P series, p equals 1/2, which is less than 1. That's enough explanation for me. Yes?
So when you do when you rewrite it into the summation notation, it's okay to change where the n starts? So now it's writing n.
No, it's not. I did that out of habit. Muscle memory. Thank you. So the sum involving this guy diverges, but this guy's even bigger, so the sum involving this guy should diverge. So we're using part 2 of the comparison test here. Does that make sense?
Oh, but wait, can you scroll back up?
Yeah. So if the sum of the smaller guys diverge, then certainly the sum of the bigger guys should diverge, right? Okay, so now the third part's just the conclusion, you guys. So, and we kind of already said it. Thus, oh, wait. Ergo what? Sum n equals 2 to infinity of 1 over. So the given series, you could actually write out the given series if you don't want to write the symbolism. The given series diverges by the comparison test, or just comparison test is fine. So 3 components of the comparison test. You're going to pick the right sequence to compare the given sequence that you're summing to. And then in step 2, you're going to, the sum of the thing you're comparing the given thing to, I hope I'm not using the word thing too much. You got to tell me what it does. Does it diverge, converge, and why? And then third, your conclusion. You're either going to use part 1 of the comparison test or part 2. It either converges or diverges based on your result in part 2.